Hello everybody, it's Dr. Novak again. This is going to be part 2 of thermodynamic substances. And I thought I would show this aquarium here because if you look at it, this is using a plenum. And basically the individual is using, it looks like it has some sword plants in it, but it has like a Nubius in it and different varieties of a Nubius. And there's really very little plants that have a roots to them, except for maybe in the back in the left-hand corner. That those look like they could be swords of some sort. But the point I'm bringing up is he's got it nicely aquascaped. He has the front open, so in the future, if he ever wants to get anything like a autumn angels or something like that in the aquarium, they got plenty of swimming space. And he's not depending on plants to keep his biological filter going. He's using a plenum, and this is something that I'm asked a lot. Can I use sand? And he has built it up where he uses different layers and then puts the sand on top of the plenum. It's good to see how other people have made their aquariums compared to what I show on my aquarium. But if you're interested, stay tuned. Bead filters, along with filters like the Nexus, which is a filter that I showed you in the first part, which is a very expensive filter used for pond use, are subject to the medium that is used in them and how much usable surface area they have available to the bacteria. Okay, some medium has a golf ball dimple in the plastic medium, and I'll show you a picture of such medium. Really sounds more promising with the plastic dimples that just a smoother surface medium has. The surface of the medium should have more of an irregularity nature to it to aid in the increasing of the polymeric surface tension properties, aiding in accelerating bacteria colonization of the media. Remember, I said in the first part, any slippery surface is a lot harder for bacteria to adhere to and do its job, because bacteria that is free floating in our aquariums is basically useless to do the nitrogen cycle. Only when it attaches itself to something that it will begin working. Plastic mediums always have a longer lag time before colonization with bacteria until a polymeric surface is established to prevent water shearing. This bacteria-made polymeric adhesion, now made up of dead cells, makes the medium not only heavier, example, which is demonstrated with the biowheel filter slowing down to the point that it may stop altogether. If you remember the biowheels, I don't know if they make them anymore, but they made a product, I think it was Penguin, made a product called the biowheel. And that biowheel spun around real fast, and they said it was like a wet-dry filter, and it claimed to have a mile's worth of filter material on it. But the trouble is they eventually start slowing down. I saw some of them stop altogether. Some of them would rock just back and forth. That's because they got heavier and heavier, and there was no other recourse to finally get rid of the wheel or try to clean it. A lot of people couldn't clean them. Okay, so now those wheels become a sticky substrate for microbial particles to adhere to in solution. Now, not only does the medium become a biological filter, but it also became a collective micromechanical filter too. Whenever a filter changes in structural integrity from biological to mechanical, that's when compromises are instituted within the filter's medium. Now you have the burden of constantly cleaning the media, and it must be extricated also or unwanted ammonia, phosphates, and nitrates will be its byproduct. It is not that the mechanics of these filters, like a Nexus filter, for example, are badly designed, which they are not. And in fact, a Nexus filter tries to separate the two in one filter mechanism, trying to make a mechanical and biological. But the medium inside them becomes the limiting factor of reducing bacterial availability. If you look at what is respectably represented out there for filtration mediums, the choices are almost unlimited. In fact, one manufacturer that makes plastic medium went as far as to add small black sponges encapsulated in the spherical plastic unit. The idea sounds good on paper, but in real life it just became a biological and mechanical filtering medium just the same. It is really a pain to take them apart and clean the little sponge that's in the center of them when they clog up with detritus. When new, they are abundant in microorganisms due to the particulate polymeric substrate surface tension because of the sponge. But that is short-lived due to clogging, because most of the mediums are used in a static state and not an active state, so detritus can easily settle on them and clog them up. What I mean is most of these mediums are placed in a filter and they just stay there and the water just passes through them. They're not like in a Nexus. The filter is constantly churning. Okay, constantly churning, and because of that churning, any particulate matter that would get on the filter medium would be knocked off. Much like your sand filters. Remember sand filters that they use for aquariums? They used to like bubble up and they were supposed to have bacteria. Remember those? They were a long tube, have white sand in them, and they would agitate the sand, and they made claims that they would carry big bacteria colonies on the sand. I don't think you really see much of them anymore. They were really a pain. But anyhow, the sponge and ceramic mediums of various sorts do achieve the desired surface meter square area desired along with a good advertisement campaign in aquatic magazines, but not in real life circumstances. I know of hobbyists that use this medium and in the end became disgusted when cleaning time came. They are time consuming to clean, or internally can't be cleaned at all and must be discarded for a new medium. And that is your ceramic mediums, your sintered mediums that are used out there. They all look good and a lot of people use them, but yes, they do become clogged and they're very hard to internally clean. And this represents a problem because we all know that when these mediums begin to clog up like that, especially saltwater hobbyists know that with live rock, when all the crevices begin to clog up, they cause algae problems, hair algae, growing from the live rock that can overtake the live rock. So they're constantly trying to keep those little cracks and crevices clean of detritus and the polymeric adhesive that adheses in them that makes it detritus stick inside the crevices. Okay? When it comes to the king of surface areas, to size particulate matter, the activated carbon is on top of the heap. 1 gram has 500 to 1500 meters square of surface area. And this can be increased even larger in some cases, depending on manufacturing processes. Due to its very small microporosity, it is not really a good biological filter medium for the nitrobacteria that hobbyists are looking for. Other sinter silica-based mediums have been made with slick advertisement on the correct microporosity of the unit. But once again, the hobbyists, through trial and error, found that they did not live up to the tasks that they were designed for. Some even made claims of dissimulative denitrification of NO3 reduction, but they clogged. and this denitrification process was rendered useless within a short period of time. You can still buy these mediums today, but the experienced hobbyist avoids them. I have boxes of this stuff at home, but it is not it's basically used for a mechanical filtration system for pre-filterization and not for biological purpose, at least not for denitrification purposes. I'll tell you that right now. Silica base just means it's a sintered glass material, which is, if you think about silica base, would be like sand. Okay? There are other biological mediums out there, some made from plastic or some other synthetic materials that is to increase the longevity of the media and to slow down deterioration of the media before it must be replaced. Some synthetic materials work in particulate polymeric substrate surfaces tensions and apply to the laws of thermodynamic substances. But the number of cells differ from media to media and can change drastically with time, and the changing of the surface tension of the adhering particulate to the substrate because of clogging. Though the available clogging of a surface of a media is still on a micro level, some hobbyists will not even give it a second thought until water parameters become depredated enough by chemical and biological insult. It is only then that the hobbyist will finally act in the form of water changes or medication. Now, excuse me, you think of medications, but this is true. The medications may go as far as feeding your koi or feeding discus, for example, garlic impregnated food the rest of their lives to ward off sickness or keeping them in a salt brine continuously because they're once again afraid of nitrite toxicity because of inadequate biological filtration. Now this happens, of course, in ponds, where a lot of people will put salt in their ponds because they're afraid of nitrite toxicity to their koi. So, of course, they put them in salt. Okay. Some hobbyists will use the excuse of salt brine because parasites, but even that gets a little lame after a while because healthy fish seldom, if ever, get infested with parasites, which is very true. I can't tell you the last time my fish have gotten sick with any kind of parasite, like ick or anything else. And that usually happens because usually new hobbyists wind up with problems like that. For some reason, they wind up with ick, and because they get too rambunctious with not knowing what they're doing, start adding a lot of fish, and all of a sudden they have parasites attacking their entire aquarium. Usually the more seasoned hobbyist has learned those lessons and doesn't quite have those problems anymore and doesn't even use the chemicals anymore for such parasites. But that was like my pond. 30 years of my pond never really had to add any kind of a chemical to it for parasites or anything. And that's pretty good. With fish being 30 years old, biological filter running for over 30 years without having really any major teardowns, just would empty the water out of the filter, clean it of any dirt, detritus, or anything, and then refilling it back up. I wouldn't touch the BCB baskets. In fact, the baskets that I have in my filters right now that have been in there for months and months and months now, I can go into them right now and you will not find any hydrogen sulfide, you will not find any blackening of the soil, nothing. And yet, it makes you think that if these baskets that are made out of kitty litter, and if the matrix is so tight on them, how is oxygen getting in there So they're not blackening in the center of them or causing hydrogen sulfide or other problems. And they're not using plants. It's just a BCB basket. If you've been watching my videos, you basically understand why it works the way it is and why these BCB baskets are not turning black or causing hydrogen sulfide or methane gases and remaining open to biological processes, right? Where other people have to advocate doing the same thing, but they have to now either use plants or something else because those processes aren't taking place. Now think about what I just said. If a BCB basket, which is, let's say, 6 inches in diameter in my, let's say, my big 88 canister filter, it's as fresh as the day I made it. So therefore, you got to start thinking, wait a second, how is this possible? How are fluids and oxygen able to move in and out of that basket without it going anaerobic? Where if other people advocate something very similar using dirt and sands and stuff like this, they advocate that you have to use plants. The question is, well, why? Why wouldn't the filter work without plants? Well, we know why it won't work without plants, because it won't work. Because you need to have a way of moving fluids through the substrate. Therefore, that's why we use a plenum, to move fluids through the substrate and not be hindered by the limitation of plants, like I showed you in the picture, the first picture of the aquarium. He doesn't have a lot of rooted plants in his aquarium, yet he's using sand, and yet his biological processes are taking place. Now, let's say 6, 7, 8 months from now, if he goes and digs into the sand that has no roots or anything in it, he's going to find out that there's no blackening, there's no hydrogen sulfide, there's no smell, there's no fishy smell, anything. Makes you start thinking that he's not using the aid of any kind of plants to keep his substrate what we call fresh. That really makes you start thinking. This is the only way that I know of that you can make anoxic conditions and keep fluids moving in and out of your substrate, even if it's sand, because of the fact we used to put sand at the bottom of aquariums long ago, back in the 70s, inch too thick, 1 inch to 2 inches thick, and the tanks got all messed up every time we tried it. Okay, the sand would start turning black, got all messed up, and we would have to empty the tank and throw away the sand. So back in the 70s, it was proven that cannot work. Now we have people that advocating that, well, it works if you try to do all these different layers, but you still need the plants. Well, why doesn't it work without the plants? It's another question that needs to be answered. Why is it so plant dependent? Why can't it do the biological processes without plants? Because not everybody can have plants. Not everybody wants plants. People want to have African cichlids, Oscars, a goldfish. Goldfish are constantly stirring up the substrate on a continuous basis. So we have to think of these animals that we want and the biological processes that take care of the ammonia they create. And will the pathways remain open? So there's a lot of good questions, like I used to do with my students, where you had a bucket and it only had holes at the bottom, maybe 4 holes at the bottom, and then you had an open cell basket and we would fill them up full of dirt. and then wait 30 to 45 days. And in the bucket that only had holes at the bottom of it, you had hydrogen sulfide already developing. But in the open cell basket that had the dirt, nothing. The soil was as good as it was the day we put it in. And there is a reason behind that, because fluids move easier through the open cell because every top, bottom, all the sides are open. So water can go in and out through convectional means, diffusion, or electrical charge. That's why that experiment worked every time we did it. And it failed in the bucket that maybe only had a few holes at the bottom, drainage holes, and they had no holes at the side or anything. That definitely is going to go anaerobic until you can get a plant in there that can start sending out a root system that could bring oxygen to that particular substrate. Where in the open cell basket, you still did not need a plant to get fluids moving in and out of it. So that is a little experiment that any grade school kid could do for a science project. Anyone can do that experiment. It works every time. But what I'm saying is you have to think about what you are doing and what are you becoming dependent on. As I've always said, plants are not dependable. They change, they die, they go dormant. There's all kinds of ifs there that happen. So we cannot depend on them solely as a means of moving water through a substrate. And I also made mention in some of my videos that a lot of people would use heating cables, which then would move water through convectional means or percolation means by heating, and therefore the hot water would exchange with cold water, constantly bringing oxygen into where the root system is. But what we found out with a system like that is the heating cables won't work in the summertime. They only work if the room is cold. Then they will constantly heat the aquarium up to the specific temperature that you have it set at. So these little experiments are great experiments that anyone could do. Anyhow, that's enough for this video, and thank you for watching. Until next time, happy fish keeping.